Good evening. I'm an educator from Kepler Educations, and this is the sixth video of the POTD series. So we will continue our POTD series as we were doing. Before starting the video, as always, I would request all of you to every viewer who is watching this video to log into our website, to sign into our website, and see the courses that are available on our platform. If you are interested in live lectures, if you are interested in live lectures at a very low cost, along with additional facilities like daily problems, as well as a problem sheet, a different problem sheet that we have created for our students, then please comment or write in the community chat group of our website that I showed you in the previous video at the very beginning. And please help us in maintaining, in achieving the numbers that we are hoping for. So before wasting any more time, let us dive into the problem that has been provided in GFC today. So the problem statement is maximize median after doing k operations. So there is an array ARR containing positive integers and an integer k. You are allowed to perform at most k operations, where in each operation you can increment any one of the array element by 1. We have to find out the maximum possible median of the array that can be achieved after performing at most k operations. Okay, so we will be provided with an array. Let us suppose the array is 1 3 4 5. This okay before my anyway. So and k value is 3. So we can increase each and every array element, any of the array element, by at most by 1. We can increase by 1 any array, and this operation is permitted k times only. So for example, if you try to increase, you have to make a median. You have to find out the maximum possible median. Now in this question, you can see that the median value is 3 plus 4 by 2. It is 3 plus 4 by 2, 7 by 2, 3. So can you write the median to be, the new median to be 3 plus 3 equals 6? Because you cannot. Because once you do 3 plus 3 equals 6, this median after this array, after being sorted, the 6 comes here and the 6 comes here. Basically the 6 comes here. So if you keep these two of them, you see the new median becomes 4. If you don't keep these two of them, then the new median becomes 5. So effectively you cannot do this thing. You cannot add k. Not possible to add k to original median, as it distorts the sorted order, and median is the middle value of the sorted order. So one thing that we have determined is that we have successfully determined one thing is that it is not possible, it is not allowed to distort the sorted order of the array. This is something that is highly important. So in no way sorted order can be distorted. Very important. This is extremely important. This is the most important point in this particular question. Now, before starting to solve the question, I will tell you that the solution first will be consider solution at the very beginning. Right now, we will only find the solution at the beginning. We will only find the solution for an array with odd number of elements. Now why? It is because in an odd number of elements there is only one median. When there comes two numbers, the average of which can be the median, some complications arise that we will treat as a special case. But once we make the odd number of elements array, once we find out the new median of the odd number of elements array, we can just write one simple condition, not so simple perhaps, but one condition, and it will be applicable to even number of elements. So before going to even number of elements, we will do it odd number of elements. Now look carefully. You can increase elements only k number of times. You can increase elements only k number of times. You can increase elements only k number of times. So let us consider this is a 7 length array. Now this would be the median, right? Now, is there any point in increasing these values? Not only the fact that there is no point, but if you increase these values, if you increase these values, then c plus p, where p is less than or equal to k, might turn out to be greater than or equal to d, or maybe let's say greater than d. Then what happens? The orange arrangement becomes d c plus p e f g. You see, sorted order distorts. Therefore, no increasing of these elements. Why there is no need to increase these elements? See, you have to find a new median, and you can make at most k increments. Therefore, you can effectively make from 0 to k increments. If you make zero increments, then your median value, then your median value remains d. But if you make k increments, your median value becomes x, which is greater than d. You say you increase this particular element. Okay, is greater than equal to d. Sorry, greater than equal to d. You equally increase this element, e plus 1, f plus 1, g plus 1. So 3 done. E plus 2, f plus 2, g plus 2. You have to do a reverse way. First e plus 1, f plus 1, g plus 1. Now to maintain the sorted order, you will again do g plus 2, effectively g plus 1. Again g plus 1. So it effectively g plus 2, then f plus 2, e plus 2, then e plus 3, e plus 4, g plus f plus 4, f plus 1, g plus 1, again g plus 1, f plus 1. And let us say k value is 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. So at this moment, you cannot increase any further. Your median remains as d. However, you have successfully made k increments, but the median remains as d. And so what I'm trying to say is that increasing these elements will not cause any problems at all, because you can maintain the sorted order. However, increasing these elements might distort the sorted order. So we will only worry about this part of the array, from the original median to the last median. Okay, so prerequisite that you need to do, that is the first thing that you need to do, you have to sort the array. You have to sort this particular array. That is a must. You have to sort this array. That is a must. So we will be only concerned with the elements from and after the median. Okay, so from and after the median. 2, 3, 4, 5, 6, 7. From and after the median. So therefore, if I is an odd number, if I should be an even number, so that is the length. Let's say length. If length is odd or length is even, because in case of even number of elements, you say that this pattern is followed. You see that this pattern is followed if there are even numbers. So these two will, okay, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So you see, this and this makes the median, their average. So increasing these three might bend the sorted order, but increasing any of them will not bend the sorted order if you make the increment logically. That is first here, then here, then here, then here, then again here, you come in a zigzag way, then the sorted order will be maintained. So this part can be increased. So for any number of length, we will only be considered from index error dot size minus 1 by 2 to error dot size minus 1. So I am writing error size, I don't know. Sorry. Let the element of the array be n. So we will be only going to be concerned with from index n plus 1 by n minus 1 by 2, sorry, to n minus 1. This is the range of indexes that we will be working upon. This is the first conclusion. Second conclusion, what will that be? You see, you have to increase. Now, if you say that your median is 5 or x, your array is A, B, C, D, E, F, G. Where you see that from D, let's say C is less than x and D, comma E, comma F, comma G here in this particular order. G greater than F greater than E greater than D greater than X. This part is very obvious because the array is sorted and all of them are greater than equal to X. Now, what is the first possible array that can be made? The first possible array that can be made, a very possible array that can be created is A, B, C, is X, 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 X. You make all these elements as X, all these 4 elements as X. Now, why this will be the optimal one? Because you see, you can make it above them. You can make it above them, but you have to check. The condition that will come is that is it possible to have at most k increment and ensure that the median is x. This is the condition that will be coming upon. Is it possible to have at most k increments and ensure that the median is x? The best possible situation where the median is x is when from the median everything is x. So you have to check, is it possible to make k increments? Is it possible to make k increments to create this particular arrangement? Is it possible to make k increments to create this particular arrangement? And what is the best method of creating this particular arrangements? At most k increments, sorry, at most. What is the best possible way for making this increment? So if anything from current median to last value is less than you're less than x, you have to make the median x. This is the condition. Therefore, you have to make the median as x. So if anything from the current median to the end of the array is, let's say, to the end of the array is less than x, make those values x. Because it is the most simple situation that can be arise. Yes, more complicated situations might arise. If you increase the last value as k, you can do that. But your median value, you can make this value increase by k times, but your median remains what it is. But you have to find a maximum median. So your only chance is to increase this particular median as well. However, increasing only this particular median distorts the array. If you only increase this particular median, this might distort the array. So to prevent the distortion, you have to find a maximum median. So if you increase the median by any amount, p less than or equal to k, it might distort the array. To safeguard ourselves from this particular hampering of the array, the only chance is to increase this particular block as much as possible to ensure that the median is x. Okay, this plus p, let's say it is m plus p equals x. So you have to increase the adjacent one as much as possible, only as much as possible to make it x. You have to increase this value only as much as possible to make it x. You have to increase this value only as much as possible to make it x. If you increase, you have to increase this value only as much as possible to make it x. Let us say you make a increment, b increment, c increment, d increment, e increment. So if a plus b plus c plus d plus e, you find it is less than or equal to k. So you have done less than k insertion, and all the values are x, So therefore, the median x is possible. However, if a plus b plus c plus d plus e is greater than k, it is not permitted to make more than k operations. It is not permitted to make more than k increments. So in this particular situation with a median as x, this combination is not possible. And if this combination is not possible, it is not possible to have median as k. You have to find out the condition. You have to find out the arrangement in the array where which is the most undistorted and least increment form of increment. Least increment form of arrangement of the array where the median will be x, and this is this one. Yes, you can increment this. You can increment this. It might be the least increment one if you only increase this. It might be the least increment if one if you do not increment at all. But in that situation, the median will remain what it is. It will remain what it will remain d, and that is not wanted. We have to increase the median. We have to increase the median. So we will consider we have increased the median to x because that is what we are searching for. This x value we will be increasing. This x value we will be increasing. We know maybe we know what will be we know what will be the minimum possible median. The minimum possible median might be a, might be d, and the maximum possible median will be e plus k. So between a to e plus k, you see the median will lie. Median will always lie, and it is x. So this x we will try to increment, and for each x we will try to make the median of the new arrangement of array as x with at most k increment. We will do at most k increment, and we will make the median as x. And the only safe, undistorting way to make the median x is to first make the current median as x, and then increase the right hand side of that median. That is those values which are greater than the median. To maintain the sorted order, increment them as much as possible, but only as much as possible, not more than that. That is, make them x. Do not make them more than x. Do not make them more than x. It is the lowest situation that can arise. Yes, you can make them more than x. You can make them more than x if it is possible to. If it is, let's say, there are k is equals 90 and you have only used 30 for a plus b plus c plus d plus e, and obviously you can increment it more. You can increment it more, but that is unnecessary. That is unnecessary. So increment them only as much as necessary, and that is when all the values are x. This is the minimum possible increment to ensure that the median increases as much as possible, which is x. That is what we're trying to make it achieve. So first, see, if the value of x is very small, if the value of x is very small, if x is very small, then obviously you'd see it is possible that the median can be okay. I mean, the number of increments that we're doing to keep the median. Okay, if the value of x is very small, if the value of x is very small, will you want that situation? No, you will not. You will not want that situation. So what can be the minimum value of this median? What can be the minimum possible value of this median? I am very sorry, it will not be a, it will be d. The minimum possible value cannot be a. The minimum possible value can be d. So you have to start increasing the median from d. The minimum possible value of the median, in which case, in the case of k equals 0, that is no increments are allowed. In that case, the minimum possible value of median will be d. So you will start from d. Now, if the value of x is very small, if the value of x is very small, just above d, let's say, just above d, you see with one increment, if this is very high, it's considerably high, this is considerably high. With one increment, you will keep the, let's say k equals 1, and the decrement between the gap between them is 2. Then you just increase this value by 1 to maintain the sorted order, and this is obviously possible. Making it x d plus 1. Let's say it is the median. This is d. This is, let's say, d plus 4. Okay. And the value of k is equals, and the value of x is, let's say, 2. Sorry, the value of k is equals 2. And you have to find out if x equals, let's say, d plus 2. Sorry, yeah, I mean, x is equals to d plus 2. X is equals d plus 2 means k will be 2. This is obvious. So let us forget about k. So let the x that we are trying to find out is d plus 2. You just make a small increase, you make it d plus 2, and you maintain the sorted order, and you see it's obviously possible. Now, one thing that you need to observe is that if x equals d plus 2 is possible, you can see it from here, x equal d plus 1 is also possible. Now, if you make it d plus 2, d plus p, you again make it t plus p, you make it f plus p, such that they're equal. You see, if d plus p as a median is possible, if d with a value of k, with the same value of k, k is constant, k has been given in the question, k is constant. So if with the value k, d plus p is possible as a median, anything less than d plus p greater than equal to d obviously is possible. Why? Very simple, because you have to make at most k increments. You make d plus q increments, where q is less than p. So you have made something less than k increments, and that is definitely possible as per the question. So if you have, if d plus p as a median is possible, then anything below d plus p is possible. But if d plus p is not possible, let us say it is d plus p, it is e plus p, this is f plus p, it is g plus p, and this is h plus p. They are all equal. But you see this p plus p plus p plus p plus p, let's say p1, p2, p3, p4, p5, p2, p3, p4, p5 is greater than k. That means it is not a possible combination. So do you think anything above d plus p1 is possible? Let us say p2, d plus p2, d plus p2, where p2 is greater than p1. You see by equation p2 plus p2 dash, sorry, p2 dash plus p2 plus p3 plus p4 plus p5 is also greater than k. So this is also not possible. Therefore, if d plus p1 is not possible as a median, then anything above d plus p2 is not possible. So for a median k, median x, sorry, x, what you have to do, what you need to do, you have to make this particular arrangement, where from the median to the end everything will be x or greater than equal to x or greater than x or greater than x. Why? Because it is maintaining the sorted order. If y was the original value in this particular position and x is less than y, then is there any point, if there you are not doing any increment for making the value of y as x, you will be doing decrement, which is not allowed. But if you keep it as y and if you keep it as z, where z is greater than y, you are maintaining the sorted order, so there is no point of doing increment. Therefore the increment will only be for these two, or maybe if this value is already from the x, if the x from the beginning, you don't have to do any increment at all. So you have to find out the number of increments that you do. You have to find the number of increments to get to the pattern of a b c d x x x x x. You have to get to this pattern. You have to find out the number of increments that are needed to done. Number of increments needed. Is this process very simple? Apparently for odd number of elements it is very simple. Okay, before that, this is the condition for binary search. You have understood binary is a question of binary search. So these are the conditions. I will mark the conditions with green. These are the conditions of binary search. First we will do linear search, obviously, from d to n minus 1, error of n minus 1. So but first we will find out this thing, how to find out the number of increments to get the pattern of this one. How to find out this number of increments? At the beginning let the array be a b c d e f g. Let us consider d is less than x, e is less than x, f is equal to x, and g is greater than x. So what are the conditions? You have to increase d to x. Let's say d plus p1, or let's say the first increment is p1 equals dx minus d. Next increment is x minus e. Here increment is not required because f equal to x, and since g is greater than x, this is maintaining the sorted order already. Therefore, no need to increase. So I guess you understood. The code is very simple. You have to check if p1 plus p2 is the number of increments. So if p1 plus p2 is less than equal to k, possible. If p1 plus p2 is greater than k, not possible. What is possible and not possible? If at most k operation increments are allowed, and the increments that you do is less than equal to k, so you can do these particular increments, and x is possible median. But if you are allowed to do k increments, at most k increments only, but if you do more than k increments, then x as median is not possible. So the code for this will be very simple. It will be, you will initialize a counter int count equals 0. Is a function int or let's say it's a boolean function, bool is possible. You will be given an array, you will be given a k, and you will be given a median. First you will initialize a counter, and then you will go for each and every element in the array. If error of I is less than, okay, you will not go from each and every element in the array. You will go from the current median to the end of the array. The position of the current median, as okay, if there is odd number of elements 0 1 2 3 4, the position of current element is 4 by 2 is equals to current median. If there is even number of elements 0 1 2 3 4 5, the number of 1 0 5, so you 4 can be replaced with 5 minus 1, and 5 is the number of size of the array. The position of the median is this 2, first median. The position of the first median is 2 2 3 5. From here you will do the things, because it is a part of the median. This 2 is also part of the calculation that are required for median. So the number of elements is 1 2 3 6, 6 minus 1 by 2, 5 by 2, which is 2, this one. So it will be position 2 is 6 minus 1 by 2, 5 by 2, which is 2. So you see, number of elements minus 1 divided by 2 gives the index of the median. Number of elements minus 1 divided by 2 gives the index of the median. So this will be n minus 1 by 2. Sorry, not here. Here of n minus 1 by 2, I greater than equal to 0, I minus minus. If error of I is less than median, we make the value as median. Count equals, this should be long because of the range that has been provided in the question, which is about 10 to the power 9. Count equals median minus error of I. If count is less than equal k, return true, return false. Is the question, is this thing this simple? For odd number of elements, this is this simple, but for even number of elements, there will be a problem. What will be the problem? Let us consider this particular example: 4 4 6 10 10 10. You see, the median currently is 8. Now you are allowed to do 2 increments only. So if you increase this 6 by 2 units, this will be 8. 8 plus 10 by 2 equals 9. This should be the maximum median. Why? if you assume the median to be 10, okay, if you assume there is no way you can do 2 increments and make the median 10. For that, the only possibility is you have to increase this by 4 units and make it 10, or you can do is that you can have to increase it by 3 units. 3 9, no, still it won't be 10. So the only possibility is by increasing it by 4 units. So the only way you can make 10 10 10 10 and the median will be 10. Anyway, so the maximum median will be 9 in this case. But while you're following the general algorithm, you see, if you're following this general algorithm, then the value of count for the median 9, for x equals 9, the general output, the general algorithm is divide 9 by 6 from 6. So 9 minus 6, that is increment in 6 by 3 times, make it 9. And since these are greater than 9, you keep them 10. Because I'm working in this section of the array, you're ignoring this section of the array. So first you're incrementing it by 3, this is incrementing it by 0, incrementing it by 0, incrementing it by 0, then you're not caring about them. So your count becomes 3. However, 9 as a median is possible, because if you increment it by 2, it becomes 8, and 8 plus 10 by 2 is positively 9. So this will give a wrong output. This will give a wrong answer. The above algorithm in this situation where there is even number of elements will give a wrong answer. Not just even. Not only, okay. I mean, for most of the event situations, this algorithm will work correctly. This algorithm will work fine. The only problem will be when the median lies here, the current median lies here, as well as the median that you are seeking also lies between these two. The only situation where this problem will take place. 1 2 3 4 5 6 7 8. The only situation where the problem will take place when the current median lies here, as well as the updated or new median will be lying here, because if the updated median lies here, If the updated median is more than this particular value, this plus this by 2, if it is much more, if it is more, sorry, yeah, if the updated median is more than this particular value or more than this particular value, definitely it will be reflected in these situations. It will be reflected in this situation. But this is the only condition when this particular situation can arise, when the current median is also here and the updated median also lies in this place, which is 6, which is 8 and 9 in this situation, 6, 10. How to get rid of this situation? You see very carefully that whenever the updated median will lie in this region, whenever the updated median will lie in this region, as well as the current median will lie in this region, you will observe that the value of count is always 1 more than k, either always 1 more than k or it is exactly equal to k. Either it is 1 more than k or it is exactly equal to k. By dry running this many times, you will if you carefully dry run this many times, you will observe this pattern. Either it is 1 more than k or it is exactly equal to k. It is not less than k, it is not much more than k. If it is much more than k, if the increment is much more than k, if k plus 2 or k plus 2 or something like that, it is increment, then this particular thing, the new median will shift. This situation is only possible when the value of k is 1, when the value of count, when the value number of increments that you are doing is 1 more than k, that is you are making it a 6, you are making the 6 as 9. The median is k, the median is 9, the median is 9, you are making this value 9. If you increase it to, let's say, 10, if you increase it to less than, let's say, 10, I repeat this entire thing once more, why it is like this. These are the target positions. You see, it is either, okay, it is, if it is 6 and if it is 10, you see, your target median is 9. One thing I can do is 6 plus 3 equals 9. If it is more than k plus 1, it's k plus 1. If it is more than k plus 1, let's say it is k plus 2, then this will be 6 plus 4 equals 10 and the new median will be 10 plus 10 by 2 is 10 and it is not equal to 9. It is not equal to 9. So if you have to keep the median as 9, if you have to keep the median as 9, as well as if you have to keep the median as 9, then you will make only one increment between these two numbers. In case of even number of places in the array, in case of even number of places in the array. So in this situation, you see, if the length of the array is even, as well as if the length of the array is even, as well as your count or the number of increments that you have done all this time is 1 more than k, and most importantly, you see that if you increase it by k number of times, which is 2 for this case, it was 2, yes, for this case it was 2, you see the median remains the same, that is 6 plus 2 equals 8, 8 plus 10 by 2, it is 9. This is the reason I am saying that count should be exactly more than k, exactly equal to k plus 1, because I will just repeat this one more time again. You have to keep the median as 9, have to keep median as 9. How to achieve these conditions? One is that you increase the lower one by k plus 1 such that the lower becomes higher, that is the left becomes equal to right, while the left becomes equal to right, and left plus right by 2 becomes 9. Or you can do something is that increase the lower by k. If you see that both of them corresponds to the same median, if you see increasing the a by k plus 1 and increasing the a by k corresponds to the same median, then you can decrease the number of increments, to k, which is well in the range of 0 to k. You can decrease the number of increments from k plus 1 to k. You can simply ignore that particular extra increase that you have done. You can ignore that simple extra increase that you have done in order to maintain the value as k. Why is it possible? It is only possible of because of integer divisions. 9 plus 10 by 2 is equal to 9, as well as 8 plus 10 by 2 is equal to 8, 9. 9 plus 10 by 2 is equals 9, and 8 plus 10 by 2 equals 9. So in this rare situation where you are getting 9 plus 10 by 2 equals 9, you have to keep the median as 9. You have to keep the median as 9. You see, 9 plus 10 by 2 equals 9. That is achieved. However, you are taking one more than k only. Then because of this particular flaw in integer division, you can decrease the value of k plus 1 to k, and you can make it 8 plus 1 by 2 equals 9. It should ideally be 9 plus 1 by 2 equals 9. It should ideally be more. It should ideally be not possible, but you can reduce the number of increments from k plus 1 to k for the value of a, for the first value, for this one. If this part is a bit confusing, I understand this part is a bit confusing. I will go it through one more time. This is let's say 6, this is let's say 10. You see, if you increase, if you have to make the median as 9. One way is to make it 9. 10 plus 9 by 2 equals 9. By a flaw in integer division, and you see it is k plus 1 number of it has occurred k plus 1 number of it. By a flaw in integer division, you see that 8 plus 8 plus 10 by 2 is also 9. So you will check. Is it possible to retain 9 as the median by discarding this extra increment? Is it possible to retain the median 9 by discarding this extra increment and making the number of increments as k, which is well in the range of 0 to k? This is only done by, it can be done by decreasing one more than one less than 9. That is increasing k by 9, increasing 6 by 2, increasing 6 by k, increasing 6 by k units, and you find that it is exactly equal to 9. Now you have to ensure you have the okay, this particular part I hope it is clear. Now another important part is that you have to ensure that for this 6, for this left, you have k number of increments left. How can this be made sure of? How can you be sure that there are k number of increments left? Only if the right, which is this one, this 10, which is 10, only if the right is more than median. Only if the right is more than the targeted median. If the right is more than targeted median, you're sure that anything after right is more than the targeted median. 11, 13, 2000, 200,000, 1 million, anything, it is more than 9. So from this right to the end, you are sure that your number of count, your number of increment has not required at all. There is no need for incrementing count at all. So effectively the value of count remains 0. So number of possible increments that you have is k. The number of possible increments that you have is k only. So you will try to increase this left value by k. You will try to increase this left value by k instead of k plus 1, which it was earlier being getting increased. Earlier it was getting increased by k plus 1. You will try to increase, and if it is increasing by k plus 1, you are sure by the above algorithm that this will be equal to k. This will be equal to 9. The value of median will be 9. You are sure the value of median will be 9. But you are trying to increase this by k. You are discarding the extra increment. And if you see that a median is the targeted median that you are hoping for, you are sure that this extra increment can be discarded and the number of increments can be brought to k, which is well in the range of 0 to k. So what are the conditions? This right, the first condition, right, which is ARR of n minus 1 by 2, must be greater than or equal to your current median. Sorry, yes, greater than or equal to, doesn't matter. Second condition, the left must be less than or equal to the targeted median. You can make it greater than or equal to, you can make it greater than, that doesn't really matter. For understanding, because for understanding, since it is a very rare case, you can make it greater than. This case doesn't appear much, but it is better to keep it as greater than or equal to, or less than or equal to. If you keep it greater than or equal to, you are also sure that in the right, no further increments will be done in the count. So you can keep it greater than or equal to without any worries. Third condition, count is equal to k plus 1. Only then you can discard this extra increment. Fourth condition, okay, the left is error of, okay, this is n by 2, right is n by 2. N minus 1 by 2 is the left one. And fourth condition, the final condition, is that the array must be of even length. Oh, sorry, there is not the most important condition. The most important condition is after discarding the extra increment, left plus k, if you increment this value, why is this done? These two ensures number of possible increments is still k. This ensures. Now, if left plus k, which is the maximum increment that you can do, plus right, since you are doing left plus k plus 1 increment, sorry, k plus 1 increments, you are discarding the extra increment. If it is same as the median, if all these conditions converge, then you will return true. I will show it in the code, or I will append it in the code, in this code. Okay, sorry, forget it. Forget it, it's not working. I will append it in the code. If first condition was ARR.size mod 2 equal to 0 and count equal to k plus 1 and num, which is the median, okay, it's the median, and it lies in the value, the count, sorry, error of n minus 1 by 2 is less than equal to median less than equal to error of n by 2, and the most important condition, error of n minus 1 by 2 plus k plus error of n by 2 by 2 equal to median. These are the 5 conditions that you have to ensure, and if these converge, you will return true. You will simply return true. You will simply return true. Let us now start the linear search. This is the overall algorithm, and if you do the linear and binary search, the binary search conditions I've already told you. Let us make one thing. Let us not do the linear search at all. Let us jump directly to the binary search. So your low, as I said, was error of n minus 1 by 2. Your high is error of n minus 1 plus k. From D to G plus k, as we had discussed. From D to G plus k, as we had discussed. High equal to error of n plus 1 n minus 1 plus k. While your low is less than equal to high, you will find mid. It will be low plus high minus low by 2 because of the constraints, which is about 10 to the power 9, I believe. Yes, 10 to the power 9. So if possible, error, it is the target median, mid comma k. If it is possible, what was the condition of binary search? I had underlined it. If it is possible, then increment needed. And since it is possible, it can be an answer. It can be an answer, and you have to maximize this median. So you will try to increment it. Else it is not an answer. And if with a target median of mid, you cannot possibly find out you cannot possibly have k increments and make the median as mid. Then you have to make less than k increments. And if you make less than k increments, you will only be achieving a maximum median which is less than mid. So this high will be mid minus 1. You have to decrement the targeted median. This is the overall binary search. Before going to the time and space complexity, let me first show you the code. So as I told you, this is the is possible function. I will do the is possible function first. So it is counting a number of increments. It will be given an array, targeted median and k. So you first find out from the median value, from the median's index, first median index to the end of the array, all those values which are less than the targeted median, you make them equal to targeted median. And for that, how many increments do you need? Num minus error of I. You count all the increments. For an odd value, or for a array with odd number of elements, this will suffice. If the count is more than k, return false. This median is not possible. If the count is less than equal to k, this target median is possible. Now, if it is even length array, if the value of count is 1 more than the targeted median, targeted number of possible increments, if the size is even, So you will try to ensure, you will try to find out whether targeted median is able to be achieved, can be achieved by disregarding the extra increment that you are doing. So you will do error of left plus k plus error of right by 2. That is, you are not doing error of left plus k plus 1, which you were earlier doing. You are disregarding the extra k plus 1 at index. Earlier you were doing k plus 1. This thing you were doing earlier. This will also be equal to num. This will also be equal to num. Mind. This will also be equal to num. Effectively, there is no point in doing this, but for you, it will suffice if we just remove this entire condition. But for verification, for some cases which I might not be able to imagine right now, for any edge case, we are keeping it for safety. So you disregard it and you see if it is exactly equal to the targeted median or not. And to ensure that you have those k increments, first, this is not necessary. Error of left is less than num. This is very obvious condition. But you have to make sure that you have the k increments with you. So you have to ensure everything from error of right, that is the right value, to the end of the array is greater than equal to num. You can make it equal to, cannot make it equal to, up to your choice, doesn't matter. So that you have to ensure that you have the k elements. If that is true, if it is done, you will return true. That is, you are disregarding the extra element. Still, you can have the median as the targeted median, which is num. Still, you can have the median which targeted median, which is num. So having num is possible. Having num is possible with k increments instead of k plus 1. You are disregarding the extra increment. You are incrementing k time, and you see that you can have the targeted median. That is possible. Then you are returning. So it is possible to have this targeted median with k number of increments. So you have to return true since it is possible. Now, the main binary search is very simple. You will first sort the array. You can take it either 0 or you can take it d, the value d that I was saying, the middle value, up to your choice. It will, error of 0 will effectively be a waste of time most of the time. Time constant will unnecessarily increase. Unnecessarily increase if you keep it error of 0. And why would that be? Because from a, there is the first value, to the original median d, this count value will always be 0. This thing will, this count, this increment, this condition will not work at all. This condition will not work at all. And so this count value will always return true. Will always return true. So this can be an median. So you will simply incrementing it to d, and from d the actual game starts. So you can keep it d for, I've kept it for safety purpose. You can make it error dot size minus 1 by 2. High is the last element increased by k number of times. So it is the answer variable initialized. I say initialized to low because I could have initialized to minus 1, I could have initialized to anything, I could have given it a random value, I don't care. And I simply don't care if I give it if I initialize with a value of low. So what is the binary search that I did? Mid equal to low plus high minus low by 2 because of the constant interval height. If it is possible, it can be a median. It can be a median, and you find out maximum median. If it is possible at median or mid, it is definitely possible for any median less than mid. And it is only because you are making less number of increments if it is less than mid, which is allowed. So you have to increment the mid. You have to go to the right of the search space. So low equal to mid plus 1. And else you are making more than k number of increments. That is not allowed. You have to make less than k number of increments. To achieve that, you have to make the targeted median less than mid. So it is high equal to mid minus 1. So now we will do the time and space complexity. First, let me run and submit it. Yes. This should submit fine. Yes, it has. All right. So you see, first is that the first point that you need to consider is we will first find out the time for this particular thing. Yes. Okay, first we will find out time for this particular thing. So is possible. What will be the time for this is possible? All right. What will be the time for, sorry. What will be the time for this particular is possible? You see, this thing from here to here is written true. This is just an if condition. The extra precaution that we are keeping for even number of arrays where the increment is only between these two, the initial increment initial median and the targeted median is only between these two. This is a simple if condition or a checking or a precaution that we are taking by an if else statement. So this will take O of one time. This thing is taking O of n time and remaining is if else. So this entire function is taking O of n time. And this binary search, the sorting is taking O of n log n time. And this binary search is taking O of 10 to the power 9 minus what is the minimum possible value. Okay, 10 to the power 9 plus key is also 10 to the power 9. 10 to the power 9 minus 10 to the power 9. So it is effectively O of 10 to the power 9 2 minus 1, which is equals O of 10 to the power 9. This did cancelled anyway. Okay, so the total time complexity becomes O of n log n. Sorry, this will be O of log of 10 to the power 9. Yeah. O of n log n plus O of n into log of 10 to the power 9. So effectively it is O of n log n plus O 9 into O of n log 10. If you leave the sorting aside, it is basically O of n log 10 into 9 complexity. This is time complexity. The space complexity is O of. Are we taking any extra space? No, we are not. So this will be O of 1. This is the time and space complexity for this algorithm. So this completes today's POTD. As before, these entire notes will be available in our website. In the resources section of our library at navbar, it will be appreciated if you comment how you liked the video, how you felt about the video, or you can comment in the community group of our group chat. Okay, community group of the resource section, community or a community library of resources section of our library at navbar. You have to sign it to be able to see it. So this concludes today's discussion. This was a medium problem, but this problem was this is actually a medium problem, but this particular condition makes this problem unique and a bit thought provoking. It might happen that you did not understand this particular algorithm even after all this time I told you. You have to rewatch this video either, or you just take a pen and paper and you think if you think for 15 minutes, you will understand this particular approach. And I don't think that will be particularly necessary because I've tried to explain this in as many ways as possible. I hope you have understood it. If not, I would recommend you either you rewatch the video, or I will recommend you do not rewatch the video, but you take a pen and paper and do it by your own. That will be much more helpful than rewatching the video. Trust me, that will be much more helpful. So this concludes today's lecture. Thank you. Hope to see you in the next one.